Swayam Prabha. Digital India. Educated India.
This one is the last lecture of this course. In this lecture, we will see some more examples as well as the applications of the remote sensing and GIS technology. So let us start with this application of remote sensing and GIS in cryospheric studies. So here, as we know, that cryosphere is basically the Earth's cover of snow and ice. So let us see how we can apply this understanding to identify or to extract some meaningful information. So just to give you a background of this problem, so let us go through this slide where I have explained how water is stored in different reservoirs. So that's why the heading of this slide is the hydrological cycle and reservoirs. So these are different reservoirs present in our Earth system. So here you can see that frozen freshwater, ice cap and glacier. So all are basically included in this, right? Let us understand this cryosphere in little bit more detail. The part of Earth's surface that remains perennially frozen constitutes the cryosphere, right? The cryosphere includes not only glacier and sea ice but also vast areas of frozen ground that lie beyond the limits of glaciers. So this is taken from this particular book. This is a very standard book in this area, The Blue Planet, an Introduction to Earth System Science. So here you can get all the different types of systems which are involved in our Earth, right? So that's why we are talking about Earth system. Now the third point here, it says nearly 30% of the Earth's land belongs to the cryosphere, where the glacier covers about 10% and perennially frozen ground covers about 20%. Altogether, cryosphere covers 30% of the land area. Now, a glacier is large, long-lasting mass of ice found on land that moves because of the gravity. Because you must have heard that glacier is moving, glacier is coming down, it is at very high speed, it is at low speed. So, why it is moving? Because of the gravity. So, those components you can study which are involved in this movement as well as this glacier formation using this remote sensing and GIS. So formation of glaciers are associated with very low temperature and other factors that are harsh for human settlement. We cannot survive in those conditions where these glaciers have been formed. In such inhospitable environment, remote sensing emerges out to be a very powerful tool for glacier investigation. Why? Because you need not have to go there, you just have to access the data captured from these satellites and you can do n number of different investigations, right? So for conventional technique, you have to visit the ground, you have to take the sample, you have to do some in situ experiments, then only you can derive meaningful information. But here when remote sensing is involved, you can do it from your office or from your lab, provided you should have access of the appropriate remote sensing data. Sensor onboard airborne and spaceborne platforms helps in data collection in different conditions. That is true. Starting from the study of dynamic motion of glacier to snow melt runoff and mass balance estimation, remote sensing and GIS have provided renewed opportunities. So there are lots of data available nowadays. So you just have to identify appropriate data suitable in your studies. In a remotely sensed image, glacier can be easily distinguished from other features through its surface albedo that we have already understood in hyperspectral remote sensing as well as the field spectroscopy part, right, where I have explained you if there is a change in or slight change in the composition, your absorption feature is going to identify that, right. On the basis of a spectral reflectance response, glacier ice can be differentiated from other features, right. So here you have typical vegetation or grass spectra. This is for the snow and this is for the soil. So you can see all these three are different. Without any spectral analysis, by looking at these spectra, you can easily find out the differences, right. So this is what qualitative analysis means. But when you are involved in quantitative, then definitely you have to quantify. For that you have to conduct spectral analysis, right. Landsat 7 and 8 with a resolution of 30 meter and several spectral band can help in distinguishing snow coverage and cloud cover from space. Specific wavelengths are sensitive to snow. Such wavelengths are widely used to compare between glacial ice and snow and also varieties of surface ice. When snow is metamorphosed to glacial ice, spectral reflectance falls from 95% to 60% in the visible range. This is from one study where you can easily find out the difference between snow, fern, glacial ice and contaminated ice from each other by looking at the spectral profile. So this is the beauty of remote sensing and GIS, where you don't have to visit the place, but definitely you need some ground data to validate it, but most of the time you can use this remote sensing and GIS directly to interpret or derive the result. Now let us see how this microwave remote sensing has been used in glacial studies. So this is one work which has been published by this gentleman. So here you can see this ERS1 SAR mosaic has been used to identify the boundaries of this snow. So binary, this is the A, right. So binary image by combining region segmented image of age enhanced mosaic and gray label representation of texture data. Now the next one is B, where noise has been removed, and in the C you can see after applying Robert age detection it has come to this level. Now our interest to just find out the boundary, then the final ice sheet boundaries have been derived again further using the filters, right. So here you can easily find out how this is changing with respect to time. So let us say this is for the 2019, right. So similarly you can find out previous year, and then you can easily find out how these boundaries are shifting either lower side or up. Imaging microwave remote sensing useful in glacial studies include this SIR data, SIR, then European Space Agency ESA, so that satellite name is ERS1 and ERS2, then Japanese JERS1, then CSAT synthetic aperture radar, that is SAR, then Canadian radar set, so radar set 1, 2. Spectral bands which are commonly used in these systems are L band, C band and X band, which are used in snow mapping, right. So what is the advantage of this microwave remote sensing in glacial studies? Because glaciers are found to be at the higher altitude. So what happens, most of the time you will have the cloud covers and the light rain, right? So because of that, the optical remote sensing data sets are not very useful. That's why this microwave remote sensing images are more useful or more used in glacial studies. So the advantage of using microwave remote sensing over optical remote sensing for glaciological studies is the cloud penetrative property. SAR data can be effectively used in snow, ice monitoring and differentiating relative ages of moraine. That is also one application. C-band can be used to recognize snow cover region from non-snow areas. So with C-band it will be very easy. Radar set C-band can be used to distinguish between firm and bare ice faces. This particular paper, they have already explored this possibility. Glacial retreat can be effectively studied using radar set data set. Radar interferometry can be used to generate 3D model. So this is another area where lots of opportunities are available. So you can think of generating a 3D model for a glacier region where you can utilize optical remote sensing as well as the microwave remote sensing data. SAR interferograms of ERS-1 and ERS-2 can help in ice flow that already these people have explored, right? Why I am explaining you all these applications? Because you need to understand the capabilities of remote sensing and GIS and their potential applications. So where you can directly use this technology as a tool and you can solve a problem which can be related to a society or maybe a nation, right? This is another work which has been published in Physical Geography. Non-imaging microwave remote sensing useful in studying glacial microtopography. This is another possibility where you can think of applying this remote sensing and GIS. So here airborne laser altimeter is used, radio echo sounder is used. Data set derived from these systems can be very useful in analyzing crevasses, morphology, spatial density and spacing, long wavelength gradient, strain rates, etc. Radio echo sounding can be helpful in determining ice thickness. So now you can see not only the surface but we are thinking about the volume also, right? These are some selected references which you can go through if you are interested in glacier related studies. So these are very good publication, you can have a look. Now let us see what is the potential application of remote sensing and GIS in groundwater exploration, right? So here I will give you a little background of this problem, why it is so important. I think you know why water is important and especially groundwater. So water present below the earth surface in pore spaces in the fractured rock formation. So basically we are talking about the soil pore spaces where water is present or the fracture of rock formation where water is present. Source of groundwater is rain and snow that falls to the ground and a portion of which percolates down into the surface, right, which makes up about 20% of the world's fresh water supply, which is about 0.61 of the entire world's water. Groundwater being the primary source of fresh water in many parts of the world, which increases its over dependency. As we know, in many parts of the world, the groundwater is the only source of fresh water, or in other words you can say for drinking water, right? So it is very demanding to study and preserve this groundwater or to explore this groundwater in certain areas where you have scarcity, right? Increasing dependence on groundwater leads to the over exploitation of this resource. That is the main reason we have to worry about our groundwater, or in other words drinking water. in this figure basically I want to explain where exactly your groundwater is, right? So you can see this is a saturated zone, this is an unsaturated zone. So basically this is our topography. So when rainfall is coming here or falling here, so it is getting percolated and it is coming to this aquifer zone, right? And why this water is present in this particular strata? Why? Because you have fractured rock or gravels where you have pore spaces which are getting filled with water, right? So basically this is the process by which your groundwater is stored or it is getting explored. Here you can see the annual water availability is this much, usable water is this much, surface water is this, groundwater is this. So you can think about some problem where you can utilize this remote sensing and GIS technology. So to address this problem, we have a satellite called GIS-II satellites, right? So role of GIS in groundwater study, it is a collaborative mission of US Space Agency NASA and German Space Agency, that is DLR. It consists of two identical satellites, namely Tom and Jerry. So one is known as Tom, another one is known as Jerry, operational since March 2002. GIS gave the first view of groundwater by primarily estimating the terrestrial water storage of the entire planet, right? I am talking about the earth, right? Now how do we determine this TWS? TWS is basically terrestrial water storage. So TWS is all forms of water stored above and below the earth's surface. So here this is the equation. I hope you are familiar with this. So TWS is equal to SM plus SR plus SWE plus GWS, where SM is soil moisture, SR is basically surface runoff, SWE is basically your snow water equivalent, GWS is basically your groundwater storage. So basically we want to derive this one if we know all other parameters, right? GRACE is the first remote sensing satellite that can estimate terrestrial water storage anomaly for the entire globe on a monthly basis. This GRACE satellite enables estimation of TWS, total water storage, at a spatial resolution of 1 degree by 1 degree, that is approximately 110 or 111 kilometer square at the equator, right? You can see this image, this is from this particular paper. So A, basically I am talking about this. So rate of change of TWS from GRACE gravity solution showing mostly anthropogenically caused groundwater loss, and B, in this figure, subtracted water storage variability predicted by CLM hydrological model from A, right? Now we have GRACE-FO. The gravity recovery and climate experiment follows on is a successor of the GRACE mission, which is basically an improved version, right, for the precise measurement. Launched on May 22nd, 2018, and this is to monitor underground water storage, the amount of water in large lake and river, soil moisture, ice sheets and glacier, and sea level caused by the addition of water to the ocean. Basically here I want to tell you that there are certain problems which are so critical, for which we have launched a dedicated satellites. So there are many such satellites which have been launched for a dedicated problem, right, or dedicated research. But apart from that, you can always explore those data sets for other type of studies, right? Let us see oceanography, how we can utilize this remote sensing and GIS. So here you can see a list of areas where you can use this remote sensing and GIS. So first one is sea surface height. You might have heard that sea surface is rising and then it is approaching the land or maybe the settlement areas. So why it is happening? Because water is coming up from the sea surface, right? So the sea surface height is an important parameter to study the climate, right? Because everything is related to each other, because we are talking about the earth system. Now the second application is sea surface temperature. Why it is important? Because that regulate your land surface temperature, wind speed and direction, currents and planetary waves, polar sea ice type and areal extent, atmospheric water content and rain rate, sediments and suspended solids, right? Height and direction distribution of ocean wells, concentration of phytoplanktons and its distribution. Because this is one very important area which we have to study to understand more about our environment, to more about our weather system or more about our climate, right? Now let us see how this remote sensing and GIS are used in these applications. So here, starting from ultraviolet to radio, this is our wavelength region, and these are very selected important areas where we want to study using this remote sensing and GIS. So let us see how we can derive this ocean color. So for that we need to use visible data. So which says the satellite which are active and can measure the images in visible wavelengths can be used to extract this ocean color. For sea surface temperature, we have to use this infrared images. For sea surface topography, wind, sea ice, sea surface salinity, we have to depend on the microwave images, right? You can see these are the list of areas where you can perform a new research, right? But for that you need to have basic understanding of remote sensing and GIS and how they are used in this particular application. Now let us see ocean color remote sensing. This is a very effective technique to study the water quality, since visible light can penetrate the surface skin of sea water, which provide direct information about oceanic constituents with specific absorption and backscattering property in the visible spectrum, such as phytoplankton, suspended and dissolved organic matter. Both active and passive remote sensing techniques can be used here, because for different types of application you need either active or passive, and what resolution you want, that decide the active or passive remote sensing data. So spectral variation in the sea surface reflectance are utilized using this particular concept, where reflectance is equal to function of absorption and backscattering, right? Oceans hold great capacity in heat storage for long time period and help stabilizing earth climate. They play key role in global heat budget by redistributing the heat content through currents and mixing processes, because we need to have a mechanism to redistribute our atmospheric temperature. Otherwise what will happen? Our surface will be too hot. So sea surface is acting as a normalization. Sea surface temperature mapping is significant in studying the heat transfer mechanism at the ocean atmosphere interface. Microwave and infrared radiometers are used for sea surface temperature mapping. You can visit some of the space agencies website and you may find some of these parameters are actually readily available to you. SST data is being used for weather prediction, ocean forecasting, fisheries forecasting and pollution monitoring. Now we are talking about ocean tides and current. Accurate measurement of ocean surface height or sea level can be done using satellite sensor for gathering long term information on the ocean tides and currents, right. Tides and currents contribute to the dynamics of ocean topography, playing vital role in the oceanic circulation and heat transport, where satellite remote sensing can give you a clear-cut picture. Satellite altimetry is being used for measurement of significant wave height and ocean currents. Particularly, synthetic aperture radar images is used in ocean wave imaging. When we talk about sea surface salinity, so basically this sea surface salinity along with SST contributes to sea water density variation triggering ocean circulation. Changes in ocean salinity content arise due to evaporation and precipitation processes as well as river runoff and ice melt. So now you can see or you can visualize all these different systems or earth systems are linked with each other. So if you have a problem in one system, that effect can be seen in another system. Ocean salinity ranges from 33 to 38 parts per thousand, and accuracy of satellite measurement of SSS sea surface salinity is about 0.2 ppt, right. So you have very accurate measurement from the satellite. Microwave radiometer and spectrometer are used for sea surface salinity measurement. Sea surface salinity is derived as a function of sea surface temperature and sea surface roughness, because all of them are linked with each other. Sea surface salinity and temperature data are used for understanding the deep water thermohaline circulation responsible for transport of heat and nutrients in the ocean. I will show you some of the case studies where people have successfully used this remote sensing technique. In this particular work, satellite altimetry data was used to study the sea level changes in the Mediterranean Sea, and which is for the 1993 to 1999. Strong correlation are observed between the sea level and temperature trends, indicating a thermal origin of the changes. Rising up to 20 mm per year has been identified in the eastern Mediterranean region and 5 to 10 mm per year in the western basin. Sea surface warming has found to affect the surface immediate and deep layer of Mediterranean Sea. In another study, this is published in Journal of Marine System, the large scale fronts in southern Indian Ocean was investigated using satellite derived sea surface temperature from NOAA Advanced Very High Resolution Radiometer, that is known as AVHRR. Monthly sea surface temperature gradient map were derived for the period of 97 to 1999 from the multi-channel sea surface temperature data of spatial resolution of 18 km. A total of 5 fronts were mapped for the first time and their spatial and temporal variability was analyzed. The study found the satellite temperature data to be efficient and consistent in providing the frontal sea surface temperature pattern of all fronts simultaneously. So that is the beauty of remote sensing from space. So you have full coverage and you can easily find out what are the changes is being occurred. Urban planning is another potential application of remote sensing and GIS. So here you can see this is land cover. So basically here we are talking about natural and self-regulated classes, right? And here we are talking about the man-made and managed land use land cover, right? So this is known as land use, this is known as land cover. So land use, how we are utilizing the land cover or the natural land cover, right? Urban planning, or most essentially urban land use planning, is a general term used to explain the process of regulating and systemizing land use of an urban area most efficiently, making optimum use of the land resources, planning and managing the population, and utilizing, leading to prevention the conflicts and chaos. Further, classifying the land use parcel according to their utility and dimension, which are most accurate and regularly updated, right? So this you can think in remote sensing and GIS data sets. Following a standardized system accepted or proposed by the authority like MOUD or Government of India, right? Land use maps are the most important tools for urban planning and modeling different urban processes and phenomena. Conventional methods for planimetric survey includes chain survey, transit theodolite, paper maps, etc. And what are the disadvantages are associated with such methods? Labor, time, cost intensive, very low temporal resolution, large number of measurements are required and chances of error increases, cannot be reproduced and updated. Attributes for particular feature cannot be attached because this is a hard copy output, right? Storage of paper map is tedious job. Now, on the other hand, when we are talking about the contemporary methods, that means latest method or the advanced methods, recent methods, digital techniques. So first one is remote sensing, then GIS, GPS, mobile mapping, then total station, right? And here what are the advantages we have? We have less labor, time and cost intensive, right? Rapid method of constructing base map in absence of detailed land survey, very high temporal resolution, so that means you will have more detail. Map can be generated at any scale according to the requirement, because let us assume that you have a data of 0.25 centimeter. You can generate very high resolution maps, but if you need very coarse resolution, then also you can reproduce this, you can resample this high resolution data to low resolution. Any number of attribute for a particular feature can be stored and accessed using digital information system. Storage and access is very easy and user friendly. Now let us see remote sensing in urban areas, how it is going to help. Remote sensing is a widely accepted contemporary technique used for acquiring information or data in urban area studies. High resolution remote sensing data is an absolute requirement for urban mapping and analysis. When we talk about spatial resolution, very high spatial resolution images are desired as urban area are mostly dense and compact and features are very small. When we talk about spectral resolution, multispectral and hyperspectral data, which gives ability to distinguish between different urban feature and their material composition, that I hope you have understood in the previous lectures. Temporal resolution, high temporal resolution can give you the changes, right? Change detection can be done using this temporal resolution. When we talk about radiometric, so when radiometric resolution is involved and you have high radiometric resolution, which enables the interpreters to differentiate between different urban entities more accurately, because you will have more labels of gray label. When we talk about 30-meter satellite images, it looks like this. When we talk about 5.8 meter, it looks like this. When we talk about 1 meter, then you have more information. So you can just think of how this spectral, spatial and radiometric resolution are going to help you. In this particular table, I just want to highlight what kind of satellite images are available. what are the different spatial resolution they have, and what scale of mapping they can produce, or what scale of map they can produce, and which can be used for different mapping level and planning level, right. So, you can just go through it, where most of the common satellites are listed. Here, this is one land use classification output. This is the level 3 land use map of Guwahati city. This is produced using this Iconos imagery and ground information, and this is from the comprehensive master plan of Guwahati metropolitan area from GMDA, right. So, you can see how much detailed mapping you can perform when you are having high spatial resolution data, right. In this particular slide, I will highlight the advantages when you have high spectral resolution. So, you can see here the vegetation, concrete and water body, they are having different spectral profile, right, and it can be used to identify different classes of urban, right. Here you can see different profiles associated with different objects, right, and how they are different from each other. This is one of the potential areas where you can utilize the high spectral resolution information. So, this is in case of urban studies. Now, here when you are having temporal resolution, so more images are available for the same area from the same satellite. You can produce such maps and you can analyze how these build up area, agriculture land, vegetation, water body, bare lands are changing with respect to time. So, basically what is happening here, one class is getting converted into another class depending upon the demands of the people. When we talk about GIS, in this phase of growing population, there is a necessity of not just urbanization but smart urbanization, right. Implementation of remote sensing and GIS technique can give urban planning a new phase that I hope you can understand by this example. Visualization, spatial analysis and spatial modeling are some of the most widely used GIS function. GIS helps to store, manipulate and analyze physical, social and economic data of a city. The multi-layered mapping feature of GIS can help in analyzing several areas such as prime agriculture land, surface water, high flood frequency, erodible areas, etc. Right. So, this is one example where GIS has been exploited to derive or to generate a thematic map of Ludhiana city. So, here you can just put the search keywords or maybe the zone, ward number and then house number, buffer size, amenity, and then you can easily find out where they are, right. So, that will get highlighted. So, it is very easy to identify any kind of information for a urban city using this GIS technique. So, there are several applications of urban land use map like urban growth modeling, urban hydrological modeling, urban disaster protection and analysis, population studies, property taxation and monitoring, utility service mapping, urban climate studies, urban transportation modeling, urban waste management studies, etc. So, these are few potential areas where you can think of utilizing this remote sensing and GIS technique. Now, let us see one of the very important area, that is hydrogeomorphology. How these rivers are playing critical role in our life, that is already well known. So, let us see how we can utilize this remote sensing and GIS in this particular problem. River are lifeline for sustainment and development of human face. The term hydrogeomorphology designates the study of landform caused by the action of water. Hydrogeomorphology is inseparable part of geomorphology, as water is one of the most important agent in forming and shaping of landform. Anthropogenic activities such as river regulation, sand mining are gradually disturbing river natural processes and forms, right. So, it is very important to monitor and see the changes of any given river system. Remote sensing has the potential to provide an invaluable complementary source of data at local to global scale, as in situ monitoring is limited in terms of spatial coverage and frequency, right. So, quantification of such fluvial alteration is essential for a sustainable river restoration and management program. After 1980s, the application of remote sensing techniques supported by new development in data analysis and interpretation led to new research on large river and to supporting the integration of geomorphology and ecology that has already been addressed in this particular paper. So, these are the different source of remotely sensed images or remote data sets. This is a very generic methodology when we talk about hydrogeomorphology studies from remotely sensed images. So, where we can think of utilizing this information for bank erosion, flood status, then what is the vegetation status in those areas, channel planform, turbidity. So, these are some of the potential areas, right. Remotely sensed images can be used for planform analysis or evaluation. So, when we have sinus river, meandering river, braided river, you can always think of utilizing this remotely sensed images from space, because that will give you a very big area coverage, right. When we talk about flood monitoring, then also you can see it can give you clear cut picture about the flood prone areas or flood plains, right. These are few references, you can go through it if you are interested in such studies. Now, with this I will end my lecture as well as this course here. I hope you have enjoyed this course and you have learned this subject. It is expected that end of this course you will be able to utilize this particular technique in your research, right. At the end of this course, I would like to acknowledge some of the eminent scientists and professors who have contributed a lot in this remote sensing and GIS domain. This is my contact detail. So, in case if you are interested, you can visit my web page. With this, I will end my course here. Thank you.